Okay, so let's just dive right in. For centuries, we've been looking up at the stars, thinking that's the next great frontier. But what if I told you that one of the biggest mysteries, one of Earth's last truly unknown landscapes, is right here on our own planet, just hidden beneath the waves? Today, we're going to talk about how a revolutionary new satellite is finally pulling back that curtain on the bottom of our oceans.
And this is a wild fact, but it's absolutely true. You'll hear scientists say it all the time. We genuinely know more about the surface of the Moon, and even Mars, than we do about our own planet's seafloor. I mean, we have these stunning, incredibly detailed maps of other worlds, but huge parts of our own ocean floor are still a complete and total mystery. Well, that's all starting to change.
So, how are we finally solving this giant planetary puzzle? Well, let me introduce you to our high-tech detective on the case, the SWOT satellite. This thing is just an incredible piece of engineering, sent into orbit to finally chart these hidden depths.
The name itself, SWOT, tells you pretty much everything you need to know about its mission. It stands for Surface, Water, and Ocean Topography. It was launched back in late 2022, and it's this brilliant team-up between NASA and the French Space Agency, CNES. Its whole job is to give us the most comprehensive look at Earth's water we've ever had.
And it is so fast. Just think about this for a second. Every 3 weeks, every 21 days, SWOT scans pretty much the entire globe. The amount of data it's pulling down is just staggering. It's giving us this constantly updating picture of our water world.
Okay, but that brings up a really fascinating question, right? SWOT is hundreds of miles up there in space. So how on Earth can it map a mountain range or a canyon that's buried miles deep under the ocean? I mean, it can't just see through the water, so it uses this incredibly clever method. And this is just brilliant. It all comes down to gravity. You see, a massive underwater mountain, what we call a seamount, it has more mass, which means it has a slightly stronger gravitational pull than the seafloor around it. And that gravity actually pulls the water on the surface towards it, creating this really subtle, almost invisible bulge, a little bump on the ocean's surface. SWOT's radar is so unbelievably precise, it can measure these tiny changes in sea level. So by mapping out all the bumps, scientists can basically reverse engineer a detailed map of the hidden landscape below.
And this isn't just some cool theory. It's already working. The results coming in are proving to be a massive breakthrough for oceanography and for Earth science in general.
Hey, but don't just take my word for it. A geophysicist named David Sandwell, over at the Scripps Institution of Oceanography, he calls it a huge jump in our mapping ability. And when the experts get this excited, something really big is happening.
To really get a sense of just how big this leap is, think about the precision. Before SWOT, our satellite maps could only really spot the huge stuff, things taller than a kilometer. But SWOT is so sensitive, it can identify features less than half that size. It's really like going from an old, blurry photograph to a super sharp, high-definition image.
So, what does that higher resolution actually get us? Well, look at this number. Before SWOT, we knew of about 44,000 seamounts. Now, thanks to SWOT's data, researchers think that number could jump to as many as 100,000. We are more than doubling our inventory of the planet's underwater mountains. It's just incredible.
Okay, so we're finding thousands of new mountains. That's really cool, but why does it really matter? I mean, this isn't just about filling in blank spots on a map. This new knowledge has some profound, real-world implications.
On a practical level, yeah, a better map means safer shipping routes, which helps prevent accidents. It also helps us figure out the best places to lay those underwater communication cables that connect our entire world. But the impact goes so much deeper. The shape of the seafloor basically tells ocean currents where to go and how to mix. That, in turn, drives global weather patterns and controls how much heat and carbon the ocean can absorb from the atmosphere. So this is absolutely crucial for our climate models. And for geologists, it's like getting a whole new blueprint of our planet, revealing secrets about plate tectonics and the forces that literally shape our world.
And SWOT isn't working alone. It's a huge player in this massive international project called Seabed 2030. The goal is super ambitious, but it's also really inspiring: to create a complete, high-resolution map of the world's entire ocean floor by the end of this decade. SWOT is helping us get there way faster than we ever thought possible.
So really, what we're all witnessing right now is the charting of Earth's true final frontier. For the first time in all of human history, we are right on the verge of finally seeing the full picture of our own planet.
And that leaves us with this one last really fascinating thought. A complete map isn't the end of the story. It's the foundation for everything that's going to come next.
It's the treasure map that's going to lead to all sorts of future discoveries. So the real question isn't just what the seafloor looks like, but with this map in hand, what other incredible secrets are we about to find hidden down there in the deep?